An animal breeder can buy 4 types of food for Vietnamese pot-bellied pigs. Each case of brand A contains 35 units of fiber, 40 units of protein, and 40 units of fat. Each case of brand B contains 70 units of fiber, 50 units of protein, and 40 units of fat. Each case of brand C contains 105 units of fiber, 60 units of protein, and 60 units of fat. Each case of brand D contains 210 units of fiber, 150 units of protein, and 100 units of fat. How many cases of each brand should the breeder mix together to obtain a food that provides 2,100 units of fiber, 1,350 units of protein, and 1,200 units of fat? Well, first off, we're going to need to have a system of equations or a matrix to represent all of this data. So we start off understanding that there are 4 brands. There's brand A, there's brand B, there is brand C, and finally we have brand D. So I'm going to set up a matrix, and I'm going to say we have brand A here, we have brand B here, we have brand C right here, and finally brand D over here. And then we're going to understand that each one of these brands contains 3 different units of something. And those something will be the fiber, the protein, and the fat. And since there are 3 things that we're dealing with, fiber, protein, and fat, I'll go ahead and write fiber here. I will write protein here. And I will write fat right here. So let's go ahead and start with brand A. Brand A, we know that it contains 35 units of fiber, so I will put that right here. It contains 40 units of protein, I will put that right here. And then it contains 40 units of fat, and we'll put that right here. Then we'll talk about brand B, which contains 70 units of fiber, we'll put that there, 50 units of protein, and 40 units of fat. Then we have brand C, which will contain 105 units of fiber, 60 units of protein, and again 60 units of fat. Then brand D has 210 units of fiber, 150 units of protein, and 100 units of fat. So that is going to be my matrix. I could just as easily write this in terms of variables if I so desired. And when you consider the problem, you'll notice that in the problem it states, let X represent the number of cases of brand A, let Y represent the number of cases of brand B, Z represent the number of cases of brand C, and W represent the number of cases of brand D. And then it further gives you some information that says there are 4 ways in which the breeder can mix brands to obtain a food that provides 2,100 units of fiber, 1,350 units of protein, and 1,200 units of fat. Okay, so if we're going to let X represent the number of cases of brand A, I can simply write X's right here, because that would be the number of cases, and I multiply that with the number of units of fiber, protein, and fat, and I know what's in each case. So we do the same thing and let Y represent the number of cases of brand B, and then we will let Z represent the number of cases of brand C. And then lastly, W represents the number of cases of brand D, so I put W's here. Now, if I were to add these together, what would they be equal to? Well, in the first case, I want to find 2,100 units of fiber. And since fiber is the first one, we would just write down 2,100. We're going to do the same thing for protein and add these together, and that's going to be equal to 1,350 units of protein. And then finally, we will add these four together, and that will represent the 1,200 units of fat. And I could easily write units of fiber. I don't have to, but I will just to make sure that I'm doing this correctly. Units of protein. And then units of fat. Okay? So this is my system of equations. It's also my matrix. Let me go ahead and rewrite that so that we can see it in matrix form. Okay, and now we have an augmented matrix right here. However, I could use row reduction to solve this, but instead I'm going to use 35x plus 70y plus 105z plus 210w, and that will be equal to 2,100. And then we'll enter a comma to separate, and then we'll type in the next two equations. And we'll see that the equations are entered, and now we'll go ahead and left click the equal sign so that we can see what's going on. And this will show you the solution, and it gives you the real solution, and you'll notice that they are all in terms of W. So the solution is x is equal to W and y is equal to 15 minus 5w and then finally z is equal to w plus 10. Okay, now that we know what x, y, and z are in terms of w, all we need to do is provide values for w to determine what x, y, and z will be. So, if we're given this statement, if w equals 0, the solution is, well, we simply will take x and we will set that equal to whatever w is, which in this particular case is 0. And then we will take y and we will set that equal to 15 minus 5 times whatever w is, which in this case happens to be 0. Therefore, we will have the value of 10. And then we will have z is equal to w plus 10, and w in this case will be 0 plus 10. Therefore, z will be equal to 10. So now I will have my answers of x is equal to 0, y is equal to 10, and z is equal to 10, which means that in this case you would purchase 0 cases of brand A and D and 10 cases each of brands C and D. And of course, that answer would be incorrect because this value should actually be 15, because 15 minus 0 is 15, not 10. So we'll go ahead and just quickly correct that, and I do apologize for that mistake. So now the next statement says if w equals 1, the solution is. So remember that the system that we came up with for a solution is the following. X equals W, Y equals 15 minus 5W, and Z equals W plus 10. So once again, we'll say X is equal to W, which in this case will be 1. And Y will be equal to 15 minus 5 times W, which in this case is 1. So in this case, we end up with 10. 15 minus 5 is 10. And then Z will be equal to W plus 10. So Z is equal to 1 plus 10. And that will yield 11. So then that means that our solutions would be 1, comma 10, comma 11, 1. Alright, so once again we've got our system, and we're going to let W be equal to 2 here. So that means that X will be equal to 2. And Y will be equal to 15 minus 5 times 2. And Z will be equal to 2 plus 10. So this right here will be equal to 15 minus 10, which is 5, and this will be equal to 12. So that means that X is 2, Y is 5, Z is 12, and W is 2. So now we ask the question, if W equals 3, the solution would be, once again, X is equal to W, so that will be equal to 3. And Y will be equal to 15 minus 5 times W, which in this case would happen to be 3. And then Z is going to be equal to W, which in this case is 3, plus 10, which will yield 13. And then this one right here would be equal to 0. So my answer will be 3, and then 0, and then 13, and then 3. And that would be the end. Of course, the question follows, why couldn't W be equal to 4? Well, in the case of if W equaled 4, then Y, which would be equal to 15 minus 5 times W, which happened to be 4 in this case, would be equal to a negative 5. And therefore it would be an inconsistent system.